So here goes your introduction to the unit circle with special right triangles. One thing you need to know is that the unit circle, the radius is always 1. And you know that sine, cosine, and tangent, SOHCAHTOA, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. However, when you look at that on a unit circle, the opposite side is y over your hypotenuse, which is your radius. The adjacent side is x over your radius, and then of course you have your opposite over adjacent. So when we're working with coordinate trig, you can say that the cosine is x over r, the sine is y over r, and tangent is y over x. Of course, that's all just SOHCAHTOA. Okay, so what we need to do is we need to quickly talk about different types of special right triangles. So you should remember 45, 45, 90, and it has this pattern L root 2, or you might have learned S root 2, doesn't matter. So if your reference angle is 45, keeping in mind that the hypotenuse, or in this case your radius, is always going to be 1, then you would need to solve for L. So to find that, you would just say L root 2 is equal to 1. So L is equal to the square root of 2 over 2. So since this is a 45, 45, 90, both of these sides are root 2 over 2. So then you need to consider your 4 different triangles that could be made with a 45-degree reference angle. And it's going to look a little bit like a bow tie. And that's because all of these angles right here are reference angles of 45. So of course you can have a 225-degree angle and stuff like that. As long as a reference angle is 45, you are good to go. So these coordinates on your unit circle are all going to have an x and y. Now remember, here's your y, here is your x. The x is on the bottom, the y is the vertical piece because our reference angle is always in relationship to the x-axis. So this is root 2 over 2, comma, root 2 over 2. And they're all going to be root 2 over 2, comma, root 2 over 2. You just have to think which one's going to be negative. So here's when x is negative, so this is negative root 2 over 2, comma, root 2 over 2. Down here, they're both negative, so this is negative root 2 over 2, comma, negative root 2 over 2. And this one is going to be root 2 over 2, comma, negative root 2 over 2. And that's how you use special right triangles to come up with these coordinates in the unit circle. Now, after you practice this a couple times, it's just going to become like second nature, and you won't need to actually use the circles. You'll just pretty much have them memorized and ready to go. So in this next example, again, the radius is always 1, but now we have a reference angle of 30 degrees. So we can draw our 4 different reference angles of 30 degrees. And of course, they're going to make some triangles with the x-axis. So this guy's 30, that's 30, this is 30, and this is 30. But we need to go back and look at our special right. So we have s root 3, and 2s. Or maybe you learned x root 3, and 2x. Or 1 root 3 and 2 and wrote a ratio. It doesn't matter how you learned it, as long as you can get it. So remember, the short side is half of the hypotenuse. So if the hypotenuse is 1, your short side is 1/2. And the side opposite of the 60 is the short side root 3, so this is 1/2 root 3, or we can just call it root 3 over 2. So in this, we have our coordinates. This is our x, this is our y. So these coordinates are root 3 over 2, comma, 1/2. Now that's the positive one. Obviously, in the last example, you know how to transfer those coordinates to all other quadrants. Just remember, the quadrants are always positive, positive, negative, positive, negative, negative, and positive, negative. Okay? So in the last one, the only thing that happens when you have a 60-degree reference angle is that the x and y switch. That's the only difference. So if our reference angle is 60, this is now your 1/2, and this is now your √3/2. So all of these coordinates are going to have the 1/2 comma √3/2. Okay, and of course you can transfer them to every other coordinate on your own. So that's that. So now what we're going to do is we're going to use it, and you're going to need to know a little bit about your special rights. You're going to have to be pretty comfortable with it. So let's go use this stuff. So we're going to sketch each angle, and we're going to state the reference angle and label the coordinates. So we have our 225-degree angle. So we're going to go 90, 180, and 45 more. And that's going to give you a reference angle of 45 degrees. So what are the coordinates of this point? Keeping in mind the radius has to be 1. Well, you just learned that in the 45, 45, 90, the coordinates are going to be √2/2, comma √2/2. Now you just have to say which one is negative, or in this case, both of them, because you are in quadrant 3. All right, so that's how you do those. So why don't you try number 2 really quick. If you got negative √3/2, comma negative 1/2, you're good to go. So you draw your angle. Your reference angle is 30 degrees. So you use your 30, 60, 90 triangle from up here. Use the 30-degree reference angle to find out that it's √3/2, comma 1/2, and you just transfer the coordinate and put the appropriate signs for quadrant 3. All right, so there's 2 more examples. I'm going to let you try both of them, and we'll see how you do. So here you go. For number 3, you should have negative √2/2, comma √2/2. And for number 4, you should have 1/2, comma √3/2. So what we're going to do just for fun is just take it a step beyond to show you where we're going with this stuff. We know that we have sine of 135. We have the cosine of 135. And we have the tangent of 135. We can find all of those based on this coordinate right here. And that's because sine, as we said, was y over r. So we just take the y coordinate. So your sine of 135 is √2/2. Because remember, your radius is 1. You don't need to divide by 1. The cosine of 135, remember, cosine is x over r. So your cosine is just negative √2/2. And then finally, your tangent of 135. That's where we just do sine divided by cosine, or y divided by x, like stated earlier. And √2/2 divided by √2/2 is just going to give you a -1 because one of the terms is negative. So that's where we're headed. So what I would like you to do really quick is just find the sine of negative 300 degrees, the cosine of negative 300 degrees, and then the tangent of negative 300 degrees, and then we will be done with this video. So go give that a try on your own using the coordinate 1/2, comma √3/2. So sine of negative 300 would be √3/2 because that's our y coordinate. Cosine is x, so it's 1/2. And tangent, remember, it's sine divided by cosine, or in this case, √3/2 times the reciprocal, which would be 2/1. So that's how you end up with the square root of 3. All right, this is Longo, and I'm out. See you, bye.